computer detection from technique from paper, in which the segmented face looks like this, and these are the ratio given in the paper. So I choose the node here now this with 0.50 length and 0.19 height at 0.50 distance from the top.
You have to understand this thing that you have control. Based of it is a normalized region, right? Now, what you are telling that if little cropping is little change, will it be affected?
No,
it will not.
Since it's a large area, I'm taking a width of 0.19, so it won't affect if the cropping is slight.
Yes, I understand. I agree. But it can be anywhere in the
box.
An area is large.
Yeah. Then, in case the highest intensity, there are multiple highest intensities, then I take the centroid of those, so that it comes closest to the most one. So, in this case, our intensity is decreased. If we select this region, we don't need to consider these which were coming in the circle. So, only these. So, these are the good results. Now, about the shifted results. Due to light source coming from this side, there is a light patch here. That is why the nose tip got shifted here. So if the light source is in front of it, then it won't affect it. And sometimes due to glare in the glass, it may also, due to this area, the glass region can also come. So if glasses are small, it will work, and what it won't work for these type of cases, where light source is coming from the left side.
Could not get you. So
if there is a sparkle in the bottom corner of the spectacle.
So then it will not. So what are the conditions? One is that.
So these are the limitations. So first of all, image should be taken from in front of the light source, and image should be cropped. That is
there.
And it should be good quality in the sense that in scanned images, it should be scanned image of a good quality image, not scanned image of a poor quality image.
What do you mean good?
Good means, I mean, the photograph, there should be a difference in the intensity level.
Yes. So if it is a case, suppose I do the image enhancement, and after this will do,
then it will work.
Okay, did you try? Can you give one? Can you show one example where the quality was bad? You have enhanced the image.
I didn't have the enhanced quality.
Do you have anything? You got the forensic size data, right? Time data you got. Can you show me one case where it will not work?
It will not work. I don't have right here.
Actually. But those things are required. Then you are telling that if I am with the goggles, but photograph is being taken from the front, then there is no problem. If it is tilted or rotated in some direction.
Tilted by a larger angle.
By large angle?
Yeah.
By what angle?
Greater than 3-4 degrees.
3-4 degrees is nothing.
5 degrees.
Are you sure?
Yeah.
Did you test? Yeah. I want to see that under what condition you can pay. It is good that 3, 4, 5. You test it. 3 to 5 degrees, 10 degrees, like that you test it. 1, 2 case only you have to take. 5 degrees take, 10 degrees, 15 degrees. After 15 degrees, I don't want also.
But I didn't have good quality images for greater than 5 degrees.
When you take, camera is there, you have your mobile phone, everybody has a mobile phone. You take,
so there is a ferret.
Huh?
Ferret has 15 degrees.
But the quality image is not.
He was good quality but rotated.
Fine quality but rotated.
वो तो उनको बताओगे वहाँ
भी सर है ये जो अपना असम वाला डाटाबेस है इसमें है
हमारा असम वाला 15 डिग्री है 5 डिग्री 10 डिग्री है
5 डिग्री
you take your camera whatever way you want but you show that it works it does not work right and what is he is telling also why don't you try that one also ferret database you have the bad quality with 5 degree 10 degree rotation you tell those things you tell where it works it is anyway it will work but where it will fail that is important to us for the future because we don't expect from you that you will give me very good but what do we expect that moderately direction has been given now we can work right
so for futurely working on this that using the nose these nostrils as a So I'll take the nostrils and take the midpoint as the nose tail. But the problem was that people have mustaches, so I was not able to identify the dark region due to that. So I was still working on it.
But कब तक खत्म कर दोगे?
So I don't know how to work for those people with mustaches. So it would work good for people without mustaches. I tested that.
No. Otherwise, what you are doing, see, mustaches has certain intensity level, and this point intensity level is above mustache area. You understand? So this is a 0, but this is not 0. So you have to take the both threshold value. You are taking one.
Yeah.
Since you are taking only one threshold value, you are facing the problem.
The nostril dark area must, mustache has dark colors, and the nostril dark area they will merge and we can't distinguish.
Why?
So mustache is up to till the nose.
No, not nose this point, nose this point. Which one you want? You want this side point?
Inside point.
Inside. That's the black.
That's the dark
But
area.
if you get the side point, you want the dark area.
Yeah. Because I can only work with the intensity. The scanning was not.
Okay, think about it. But that is you are closing your thing. You don't want to work on this.
I can extend.
Cop. Extend the cop.
But
But for this course, up to this is okay, right? Previous one. So can you give me the 3, 4, 5, 4 page write up also? Right? Because what you have done, you have to tell, no? Because otherwise, it will be done.
in this, this was error due to that segmentation.
What is
There's
it?
only one error in the 2800 images.
What is one error? You are showing so many
No,
errors.
due to that segmentation. It
What
was
does
that
it mean? What is segmentation is okay?
those two is little shifted up. No?
But segmentation is okay.
Segmentation doesn't cover this part. Due to
That is then you told
only
me that you have enough.
one case out of 28.
No, that is your this area also you have to increase.
Only for one case, then it will increase defects in other cases.
So if you increase, what happens?
It will consider
More
for example,
than-
more pixels.
How many pixels? How many features? Extra features.
Yeah. So
How many? If you increase little, can you if you fuse it, both the circular one? What was the area? The bigger area.
yeah, bigger and circular. So this is rectangularly large.
Circular area. Do you remember? What can you show me the circular area? How much it is?
It's radius is 1/3 of it.
1/3 of the width, and it was covering too many.
Too many pixels because it was covering these cheap pixels. So I will
But circle also used to give you the result.
yeah. Circle it was 85% accuracy. This was 90%.
But for this case, circle result there are. Yes or no?
Yes, sir.
Yes, sir.
sir. Can you combine both of these techniques?
But combined, which one is correct? How do you know? Probable case. You can tell both the same.
Same weightage.
Probable. That this or this, right?
Okay, provide two
So why
cases.
don't you do this one? That combine both the things, and you tell one of the things is correct, right? And then we work out how best you can get it, right? So you combine both. This is okay.
Good morning, everyone. Our topic was to predict the quality of the finger knuckle and to implement this paper, the novel Rees transform based coding scheme. So our accuracy comes out, we tested on 100 subjects and the accuracy comes out on 70.5%. And the ERR was 21.1%. For 15 subjects, the CRR was 76% and ERR was 18.7%.
So this is the result for the recognition. Now, can you tell me, what does it mean? That this is 100 subjects, this is Aditya Sorisha, right?
How many images are in a file subject? 6?
6 testing images and 16.
Achha, there are 12 images.
Aditya, class,
If any after
तुम्हारा material. somewhere.
Any other
training image,
then the CRS page.
then you say it's okay.
No, it's not okay then.
Yes. If you are matching with one image,
Same
from
with the same folder.
there are 6 matches actually. All 6 should match, or only even a single match happens, you are thinking it's okay.
With the single matches,
Uh,
if we take the score, so if the score of the one image is less than the image of the distance, whether in distance,
that's okay, but I just wanted to say
The score with the images of same folder
No, it's
list, then you say that we match.
class.
okay, you have the 6 accepted or not accepted kind of thing.
Okay, exactly.
In the testing, if you get an image, in the training you have to match that with 6 images.
no,
Not 6 images.
we have to test all the images, the 100 to 6.
That's okay, but I'm just talking about the genuine method.
Yeah.
And for the design.
Then all the 6 matches, then you say okay, or any one of them matches, then you say okay.
Anyone, the score.
Any one matches.
Anyone.
It's a match.
क्या हुआ?
Yeah, I was saying that in the testing set, if I get an image, in the genuine matches I have 6 images in the training. So
one he has taken this side and
like there are 6 in the training, 6 in the testing.
In each folder there are 12.
I said, what do you mean? Probe image number of cases 6. And query image there are 6. No.
No.
There are 12 image, right?
There is
Okay.
in each one subject.
Here one subject.
And
So 6 of them you put in query.
So we put for one image, we match it with the 100 in for all the folders we match for in the training set.
Couldn't get you.
Means one images is matched with
There are session 1,
600.
session 2.
Yes.
Right? 6 image under session 1.
Yes.
6 image under session 2. Then what?
And then we put a image from session 2 and match with all the images of session 1.
Oh.
All the objects.
So that means I understand now. Best would be that you first take, for you study, first you take one image of session 1 and one image of session 2, you match. Then you take 2 images of session 1 and 1 image of session 2, match. Then 3 image, 6 image, finally you get 11 image and 1 session, 11 is there, 12 image, 11 image and 1. Then you find that this 70 you are telling that is correct, because if you take 11 image, this will shoot, CRR will shoot. Because you get enough chance to fail. Am I right? I think then it, but 50 subject में क्यों बच्चे? उसका कोई मतलब नहीं है, because 11 में 70 में 1000 में 100 में 70, and if I increase to 1000, it will come down to 30.
You will not drop. So
Why? I can tell you, I will give you 1000 data and you check that CRR will come down to 30. Okay? This is because it needs training. That may be the reason. Right? So please check this one. You understood? 1 against 1, 2 against 1. Query will be 1, but training, then you will find that it started reducing. 3, 4, 11 you take it for training and 1, then you find that CRR will increase. Is it clear? Okay. Then quality now, quality is important.
We have basically these 4 qualities: focus, quality of edges, coefficient of distance one, and the last one is entropy. These 4 parameters.
Coefficient of
These transforms we are using.
for coefficient we are using the is code transform bit code. So we are using that quality. That is an indicator of whether to predict the quality of the code.
entropy means what?
Entropy, basically we are first applying the LPP on the whole image, then we are calculating the entropy. So means greater with the entropy, basically greater the randomness, so we can extract different type of features.
Entropy should be high, you want,
In edges, basically we are.
but in the noise, let's understand this question. If it is a noise, it has the highest entropy. Okay, nothing is there. At least you have some boundary.
First we are actually applying the LPP, so basically it will reduce that thing.
But you must have some boundary, because after that everything can become annoyance.
Boundary means?
Boundary means so that you should understand that.
No, what they have done? First, they have used some either concentric or local base. So what they have done, that they have illumination component as far as possible they have reduced. Now, what you can tell that okay, there are that due to the focus, what happens in the central area, you may have the very high intensity. Those areas you can reduce. That is, but if there is no way he can or they can think that this is the noise, because for this area only focus may be there, high focus will be there.
So in that sense, I think that whatever they are doing, since they are starting from the knuckle image, that can be a boundary. The initial image should be a knuckle image. Because
This is only knuckle image.
This
is knuckle image.
That
They are getting knuckle image.
Yeah.
Only what we want to do, we have to estimate the quality. Based on that, we can tell that if the quality is this, accuracy will be this.
yes.
On these edges, basically we are first partitioning the whole image into 10 cross 10 block, and we are calculating the number of edges by Kenny's detector. On
What is the image size? First you tell me.
110 into 220. 110 into 220.
220. So 10 cross 10 is actually block you got. There is no overlapping.
No.
Without overlapping, can you find out the age?
Average number of edges.
You want to find out number of edges?
Yes.
Gotcha.
So
But how then why do you, but if you block it, you draw the one rectangle you draw, the 10 by 10 inside you make, some small partition you make. Another one, you write another one. Now you draw some edge which is crossing these two. And another edge with another block you write. Another edge you draw. Now you tell me, without overlapping, how can you, is it possible to determine the number of edges? Because how many edges are there in your case here? You will get 4, but it's not 4, it is 2. Am I right?
Yes.
So, how are you going to?
But in the relative sense, means we are applying the same thing on all the images. So
Okay.
basically on an average, this will not means.
No. Since I have taken two blocks, you take 3 blocks, and one is overlapping here, another one is here. Then there are 2 edges, right? In practical, you will get 4.
Actually, we partition the whole image into 10 cross 10 block. The image is some portion is dark. So basically number.
Basically, what is edges? Edges is the number of connected components you want to find out. Given an edge, you want to find out the number of connected components. That is the thing. So, to obtain the number of connected components, why do you need to block them?
So if you see, first we apply without block, then maybe there is some dark area, then
It
on
considers
that part
that
the number of edges.
No. First you block, make the block area, small block, and you do in some methodology to make that reach in all respects, same intensity level. You understood? Is it
We
clear?
can apply something.
कर दो ना, कुछ करके minus कर दो, then multiply by some factor, then it will become reach. Once it becomes the reach, then you find out the number of connected components. This is not, this is a wrong word. Age is not the correct thing, number of ages. Right? And what is the appropriate number of ages? That is also fixed. For if you see the every knuckle, there is appropriate number of ages are fixed. Right? Suppose you got 2, then obviously the quality score. If it is 5, is it 2? So you check that what is the average number of knuckles. So that is visible. You don't have to find out any literature. If it is less than that, you tell that quality comes down, right? So that is the thing you want to do, right? So find the number of connected components. So this is the useful number of connected components. Okay, mid 5, mid 5. Huh? Quality. What is the formula? What is that? 11.5.
It's an average on, it's an average on each block.
If it is high, then it is good, or
If it is high, then
and 11.8 to 11.5 you have shown 5 images according to your method, which are the best, and then the mid images, mid 5 images, in which you are saying that it is 10.5 to 10.51.
Right. Then because of this reason, you have to find out, you don't need to do this, you just find out the number of connected components. That will be, and you know the number of, here, suppose it is 1 you got, then obviously it is not a good image. Right? But how many lines are there? 1, 2, 3, count it, magnifying glass, there you go. And that many should be there. No? You ask how many lines are there, he will tell you how many lines are there. For you, how many lines. Then you know that this is bottom line. This is more than that, you can tell always good.
Basically,
This is okay. Entropy is okay. Only issue is that, as Kamlesh is telling, that you must ensure that noise is not there. So now noise means that for you is the focus. Right? If highly focused, then basically nothing is visible, noise is there. Right? So you are taking that entropy of whole image together or blockwise block?
whole image. First we use LVP, then we
Whole image entropy. Why not that? Here I feel that if you take the blockwise and you obtain the entropy of the blockwise and you assume that suppose X number of entropy is very high, X number of block space is very high, then you tell high. Then his problem may be solved. What they are telling that in between the light is there, so it will come the dark. That is basically noise. So each block you find out the entropy. How many blocks of your image are having high entropy? Suppose out of 100, 10 of them are having very high entropy. Is it good image? Obviously we tell no. Right? But if out of 190 of them are having very good entropy, then you tell that it is a good image. And now in between things you put some other word. Okay? Chalo. This is I don't know what it gives.
Basically, there is one reference image we can choose that this is a good image. Now we given another image and we have to basically find the distortion with respect to this image.
So you have one ideal image.
Some 50 reference images you have given.
50 images.
How you have chosen? Eventually you have chosen some 50 images which you say that they are good images. Okay.
And basically we obtained for both images Rx, Ry.
With the 5 coefficients, the first order and the second order coefficients of the X transform.
Okay. It's correlation coefficient type thing. Okay.
For the whole image, Rx is for whole image. Okay.
Between the two images, right?
So between the two images, but this Rx will actually be not a value; it's a matrix. And R, X, Y, X, and all of them are a same size matrix as of the image.
No, matrix gives you what? What is Rij?
That is some coefficient that they have. That's a rich transform they have calculated.
What is Rij?
Rij is the least transform of the X in the XY coordinate. Rxy is the for second order.
Do you feel, I don't know, these two images should be registered?
If they are registered, then the values will be correct, or correlation, or whatever you are doing.
You understand what will be registered? This is 1, 2, and you take the two images of same thing and occur, that this center point must be center point there also.
So we have taken images from the different folders, different subjects. So we have taken a reference image from the best. We have taken a reference image. The images we have taken for the testing are not for the same objects. We have taken for the reference objects.
No, that's okay. You don't really, suppose there is a shift of the same thing. The same result you will get Rx, Ry, Rxx.
Basically, we
You take one image, that image and the same image. That
Of
image
same
was-
finger.
Same finger, same image.
Yeah, actually,
Only rotated by or shifted by, translated by X. Will the result will be same?
no, sir.
Then but quality will be very good. The finger is shifted or little tilted.
so we can use Gabor function also in this. We can.
इसको justify करो क्या use करोगे बाद में?
So what they have actually suggested is that for recognition they are using the Ritz transform based coefficients for features.
What is that one is they will
Yeah. So now they are saying that ultimately while recognizing we will be using this thing, Ritz transforms and all. So how well they are, something like that you wanted to say, because ultimately you are working on this Ritz transforms and all, right? What these parameters will be giving us like Rx, Ry, Rxx, Xy and Yy, right? What they are giving? Do you know what is the physical significance, or they are rotational invariant and things, because it's written on the paper?
RSX is not. Gabor function takes in the recognition part.
Okay, so you have also that 6. So out of this, only 3 things that you have used for features, and rest of the 3 are from the comp code. So what are those 3?
These 3 or those 3?
No, here, out of all these 5,
RSX,
These only
2D things, XX, XY and YY. Okay, so ultimately you get these XX, XY and YY, these are the real numbers, matrix. Then what you are suggesting?
Basically, we can find a different matrix Rx.
Rx and Ry, and this 5 matrix you will be getting.
Yes, sir.
Then
After that, we basically
element product.
we find a
Then we apply the mask and then we direct the image and then we find this coefficients and then we multiply them
individually,
individual element by element.
element by element.
For each. Then we after this difference matrix.
Then
We get a distortion sum. Distortion
D0 into D1 into D2 into D3.
from that, how you are estimating the quantity?
Means
That's why the low distortions are more.
Is it giving you anything relevant?
yes.
Show some result. This is best.
All this.
This is a project which is not.
No, this is rotate this a little. Yeah, here. No, screen. Oh, yeah, not this. This is the best part.
So more work can be done as we have suggested that we haven't taken up the rotation invariant.
And we can use 3D transform.
We can use 3D transform or we can use Gabor code 2 in it.
So you are saying that it's not working properly.
It's working properly but more work can be done on this.
Is it working properly? I mean, whatever you are saying, best 5. Visually, if you see and you can say that best 5, worst 5 and mid 5, they are
Yes, sir.
discriminative.
Yes sir.
This is better.
But we can is
There is a bulging side in this finger knuckle. Bulging side.
there is not any is
On the center.
And then
And in the previous area, are you, I mean, can you see on that screen, are you seeing the images? They are better.
first image is better on the rest.
Let's go back. So here you can see that these images are, you can say this is good, but this is not that much bad, because here you are seeing several, you can see that these images are lot more blurred than this one. Even you can say that, you just check that whether you have, I mean, shown the correct images, because according to me, and what are the worst? Even worst are
Worst is,
better.
the
Ah,
reverse
even
one.
the worst, yes.
Reverse one. What
Yeah.
has come much softer line.
Sharp line. I think that if you have, I mean, plotted it, shown the wrong images, then it may be, but according to me, worst and the mid one are better than the
It's
best.
the reverse one.
Yes.
This is reverse one. Okay, what does it mean good, bad? That has to be defined.
Because do you know that you have calculated something, what it is suggesting, you don't know. These are some of the parameters, right? So according to that you got some value. Then you have arranged in the ascending order. Are you sure that this is the getting the maximum, that is the best image, or it is in the
For the same image, the score is 1. So we have ordered according to that.
We were thinking that basically maybe if we can use only images in the same folder basically.
so for the okay, so one is the best match, so it means that if the value is high, then it is good. So the reference images that you have chosen it properly, because results for this are not consistent.
Gabor code can also be used.
Maybe we are
In the form, so I can tell you one parameter, and it may be like that you are using 6 bits for your feature extraction. 3 are from the bridge parameter, bridge transforms, and rest of them are from the COM code. So what you can do is that you can use that COM code information. Because you are not sure about bridge transform, I know that what physically it is doing, but you are sure about the COM code. So use that, you can see that how much variation that you are getting for COM code thing. Because suppose that what you do in COM code is that you take a pixel, you apply 8 Gabor filters or 3 or 6 whatever, and then you see that which Gabor filter is giving you a response. In the place of that, now you can check that what is the best response and what is the second best response. And then find out that if the second best response is the ratio between first and the second is a bit more, then you can say that it is having a proper orientation. And then in this way, out of that COM code, you try to find out the number of pixels which are having a clear cut discriminative orientation. It will tell you that how well image is, because it is having more discriminative orientation. How to use that, I don't know, because there is a paper from the same authors. I think that you have read that paper. Yeah, though they have said that they have used these risk transformation parameters for quality estimation, not of the knuckle. That is on the image. So how you can use that? I mean, that is the thing that you will have to do. Right?
So, but how? What is the plan of action now? When are you going to do it?
Basically, we can use COM coding instead of this.
But what is the time frame now? What you will be doing and what time frame?
So we use that focus on the middle part as an indicator to predict the quality of the image. So if what we do is that we focus this image of this image and we find out the average focus on this in this middle part. If the image is well focused, then there will be more features will be visible. So we use this as a parameter. So these are the best size because the middle part is well focused here. And
This is often correctly, right? This is very okay. This work. Focus parameter is correct. That first these are focus parameter. And after that, but you do not have to tell at this moment you are not telling which one is best and good. You are telling that this parameter can be used. After that we will take. Only thing is that the transformation for risk transformation part is check and do it, and another one is that other one, that entropy things and first parameter what is that? Age. That is not age, that should be number of connected components. Now you tell me what you have done.
So this paper explains three basic phenomena from which we can generate natural biometrics. One is by Cartesian transformation. Another is the Fourier transformation. The last one which I am implementing is the functional transformation. So what happens in Cartesian transform is like, let me give you an example.
You tell your thing. You have not used Cartesian, you have not used polar. You tell your thing. And what is the result you are expecting and why you are not getting that? You tell what is functional transformation.
So expression is x plus plus cos phi. That would be summation. So this and similarly, okay. So this is a sample electron potential function. So invertibility, the function should be non-invertible. That it can be one way. It should not be. We cannot do the other way. So G is the Gaussian function.
So Gaussian function of course is other. Is there anyone who doesn't know Gaussian function?
Everybody knows Gaussian function. So this is the transformation, and the expected result rates are.
What is the expectation?
So for functional transformation, the expected result should be around something like this curve. So for false acceptance rate of 10%, the general expected rate should be around 0.9%. Little less than that.
So this is ROC part. Not ROC. Is it ROC?
This is a genuine and this is
Is it an ROC car? Sure.
This is on which database?
this
No,
is
it is an expectation.
I gave something.
I give something. It is a nonlinear paper. Huh? But you were supposed to present, your presentation was delayed, right? Last time.
Last time, sir, I thought that was the final. I didn't know it was a two part. I thought 13 was the final one. So
Why you thought like that? Okay.
I kind of.
Yeah, but your thing is not yet ready.
Yes.
So you have to show from there tomorrow. Now who is coming? What is your
9610.
huh?
9610.
9610.
Good morning, everybody. My presentation is efficient iris recognition by characterizing key local variables. I have implemented this paper. First, I have generated one-dimensional intensity signal, and a new intensity signal matrix is generated. I have applied the Wheeler transform on it. First, I have given a 64 cross 256 image. In that, I have taken first row, in this 64 rows, I have clubbed 3 rows, and I have generated a matrix of 21 cross 256. And applied a Wheeler transform on the obtained signal matrix. This is the signal matrix I have obtained. after the signal matrix, I have to extract the feature vector for the obtained signal matrix. So in order to do that, I have to select a threshold to convert the signal matrix into a feature vector matrix. The selection of this threshold is a very big problem, because I don't know exactly for what value the best results will be coming. And for the mask which was given to me is also 64 plus 256. So I have to convert it into, in order to match this, I have to convert it into 21 plus 256. So what I have done is, I have taken three rows. If I have checked it, whether if 2 zeros are occurring, then I have set it to 0, or if 2 ones are occurring, I have set it to 1. So majority of that I have taken, and I have tuned it according to the given signal matrix. And finally I have found the Hamming distance between the feature vectors. Taking different various thresholds, I have found out FRR and CRR on that. First I have taken it as, in MATLAB we have a gray thresh function which automatically, depending upon the intensity of the pixels, it automatically sets the value. But seeing that the results were very weak, so I have consulted Aditya sir, and he has suggested me to check for the various thresholds. So I have taken threshold as 0 and 0.1, 0.2, 0.3, 0.4 and so on till 0.7. And after I have found after certain value it increased, and after that it again got decreased. So I have checked it for 0.15. I have set it up to 0.3. It has 66 and 65. I mean it was decreasing. So I have selected it and again tuned it to 0.15. So I got roughly 75.8 CRR. If we again go on setting this threshold, I can say that this accuracy goes on.
Because the value you got is very poor value for ID. Am I right?
Yes.
Now, only thing is that whatever you algorithm method you have used, that will be useful to you, right? That is the thing that is given image whether you have obtained that because it is you have taken one-dimensional reduction. Why one-dimensional? Why not two-dimensional? Right? You have reduced to 281 by 256. And the second thing is that the method you have followed on your image is different from the method you followed on the mask.
In mask,
no, that is a 64 confidence.
I have got a 21%.
No, that's okay. But what methodology you have used? Then there is something 0, 0, then you put 0 and you 1.
If I have summed it, 3 of them I have summed it. Sum of these 3, if it is greater than 1, because if it is greater than if one is occurring in the 3 rows, then it is I have not considered it, because 2 zeros are there. So if it is sum is greater than 1, again I have applied the same.
What I suggested is that there may be, because after doing a lot of experimentation, he has said that up to 76% you are getting, and the paper is saying almost 100%. And the EER is very small, also EER is very small. What is your EER?
24.
24%. The EER is less than 1% in that. So what I have said is that you just check your code once again, because there may be some small error. Also I have pointed in someone else on the knuckle print, they were saying that 15% or 20%, and after that they came to me and said now it is 70% straightforward. So there may be some problem in the code. Just try to fix it. Otherwise, there may be some more experimentation. But whatever you have done, I'll see that how much effort.
So good morning again. My project on is to estimate the quality of iris mesh based on the different quality parameters. These are the different quality parameters here. I have used these two angular measure and center distance I have introduced, and these are to calculate the specular reflection. To calculate the eccentric distance, I have considered the equilibrium distance between the center of iris and pupil and normalized it by dividing by it by 10. So the maximum value for the database is coming around 10. So I have normalized divided by 10 and normalized between 0 to 1. And the higher the value of the distance, the lower is the quality. And the angular assessment is the angle between the two centers, line joining the two centers. So again this value will be between minus pi by 2 to pi by 2. So I have taken the absolute value, means I have converted the negative values to positive and divided by it by 90. So it again get normalized between 0 to 1. Or I have calculated estimated the parameters for all database KCL, LAMP, interval, IT session 1 and session 2. So here the lower specular reflection means the higher quality. So for ITK session 1 database.
More the value, better is the quality?
No. More the value, the lower is the quality. Specular reflection.
Okay.
This images are again. Again for dilation. The more value of dilation, the lower. So this is good.
The dilation and specular reflection, you have used the same thing. What modification you have done on those parameters?
For dilation, he has considered this formula, and I have considered this formula. There is nothing.
Exactly same.
No, he has considered this.
It is not different. If you subtract it by subtracted it by 1, it is just like that. Whatever he is saying that means more is better and less is poor, everything will be ulta. But exactly you are using the same thing.
Yes, sir. But I have used the two new quality parameters.
That is okay. So for dilation it is exactly the same. You have not changed any methodology. For the other one,
Specular reflection, same.
exactly same.
No, simply 1 minus. He has considered the higher the value.
So why you have subtracted? Why you have done that?
No, for the eccentric distance, I have. If the eccentric distance is higher, then the poor quality. So I.
Okay, you just wanted to make them consistent.
Yes, sir.
Otherwise, there is no change. You have suggested 2 new parameters.
Yes, sir.
Okay, let's show
Suggested 3 parameters, but I am not able to calculate the open angle.
Okay. So one is the eccentric distance that you have taken, the distance between the iris and the pupil, right?
And the angle between.
And the angle between them. You show the results for that.
This is the opposite.
That's okay. And it's like that. Results are exactly same as that of the unweight or what? Unweight, right?
This is the eccentric distance.
Ah.
So most of the images they have 0.5.
It means what? It's a distance. So most of the images are having distance like 0.5.
It is normalized between 0 to 1.
Okay.
The maximum value is around 10 to it will be around 5.
This most of the images something like half. 3,400 images are having exactly the same value. Exactly the same value.
Around. Yes. So
Okay.
it will be 0.1.
Okay, fine.
Total database for this is 10,200. This is the angular measure part.
Angular measure.
Yes, sir.
Most of them are having 0.7. About 1,000.
Yes, sir.
And then it is 0.9. There are most of them are having 0.9.
Yes, sir.
7,000, 8,000 images are having 0.9 angular measure.
What does it mean? They are poor?
What does it? They are poor or good? More angular measure
So I have not used these images for recognition and.
No. What does meaning?
It's just like a suppose.
They are poor, but visually it is not visible.
Visually it's not visible. You show some results also. You are having the images.
No, I have not seen these images.
Why?
Huh?
If you
No,
have
it is not. You cannot see with the eyes the angle.
How can you justify this correct?
See, I am not saying that this distance.
This angle will be not visible in.
That is okay, but if you are saying that this image is good and this image is bad with respect to your any measure, then we at least wanted to see that why you are saying. There should have to be some justification behind that. That why you are saying this image is good and this image is bad, right?
So for the ascending distance part, I have clear the distance is larger than the segmentation method. If we are considering them as a concentric circles and doing the segmentation, then it will result in poor segmentation and normalization.
That is correct. It means that the distance between two centers, if it is more,
then we cannot segment it using the
segmentation will be a problematic issue.
If we do it by considering it concentric circles, then it will be.
So we assume that it is circular, and then we assume that it is concentric circles, and then we normalize it. And you are saying that if the distance between both of them is huge, then this assumption will fail, and the normalized images will be distorted. Right? We want to see that distortion. You got it?
You justify.
So I can collect images.
That's also
required. Otherwise, it will be difficult.
For the classification, I use if I do the supervised classification, then I have to label all the images, its quality 1, 2, 3, 4, 5. So I have used the semi supervised classification. So first I clustered all the images based on the quality parameters and assign them cluster 1, 2, 3, 4, 5. All 8 parameters I have given more weight to occlusion, specular
the same as Anvesh has done, but like he has used 6 parameters, you are having 8 parameters.
And he has done it manually.
Okay. So given all of the images, you have found out all of these 8 parameters.
Yes, sir.
And every image is now a point in this 8-dimensional space.
You can assign it manually to this image by usually looking at these images. But
Okay.
I have not done this. I have done it using clustering.
Which clustering? K-mean clustering?
No, K-means no. Hierarchical clustering.
Hierarchical clustering.
Yes, sir.
So you have done it on MATLAB or
MATLAB.
Yes. So for each image you are having this 8 parameters.
Yes.
So in 8-dimensional space it's a point.
Yes, sir.
Right? So all of these points you have clustered using hierarchical clustering, and you have found out how many clusters? 5.
Five clusters.
5 clusters.
Yes, sir.
And how many images you have
The
clustered?
good images will cluster together and.
Okay. So
So I
7,000 images.
for the 10,000 images I have clustered it.
Okay.
And again taking 7,000 from this I have trained the classifier.
How many total images you have? 10,000.
10,000 for IDK.
Classifier for training purpose and because 210 is tested.
So accuracy is 86%.
How you have calculated the accuracy?
Huh?
How you have calculated?
Testing data.
So that is fine, but for
You have
every
to see, I understand. What you have done, you have considered the same cluster, right? Check to whether he is lying in the same cluster, right? But it failed, it is. But
No, its accuracy is 86%. 86%. Yes,
40% it failed.
Yes, sir.
Right?
But
So this is because of the reason, there is a problem that because of some reason that it has gone to the neighboring cluster. So you should have checked the neighboring cluster.
Yes, sir. This can be done, but if we assign it manually, then it will result in higher.
No, manual itself comes right.
what you are saying is that if you choose the image more carefully, you want to do this.
Yes.
If you choose images more carefully,
Yes, sir.
then this clustering algorithm will work fine.
No, clustering, the classification algorithm can be improved. The result of classification.
I mean, ultimately you will be your classifier will be trained.
Yes,
Yeah.
yes, sir.
Your classifier is what? It's a clustering.
Yes, sir. Naive-based classification.
Naive-based classifier means what you are doing for classification. You take when new image came, How you
trained the
classify?
database. I have
5 classes you have.
5 classes I have. I input the all 8 quality parameters. It will result between 1 to 5.
How? What it does?
What it does? How you are getting
What is nice
this cluster
classifier?
1?
You have used some algorithm or
No,
you have done it?
it is given in MATLAB new version. So I have
Have you done it?
Huh?
No, he
No, I
doesn't do it.
have implemented it. So I have implemented
Have you read what it does?
So what is that type classifier? What it is doing?
No,
Find out
have
the
you-
ingredient.
Have you read that? That is our question.
You don't know what it is doing, right?
Sir, I don't
Okay. So
Data.
see that because tomorrow when you come to me, then you tell me that what it is doing. I will try to understand it, what it is doing. Because maybe better clustering and maybe better classification will help. And also, as you are suggesting, manual or more carefully, if you select some training images, then this clusters will be more intact or meaningful.
No, the training, the class levels we are assigning.
That's
But
not
we
what
are,
is
if it is the class level is manual.
Non-supervised and supervised classes, he has used both.
Yes, sir.
Right? He says that now what he is telling that tomorrow you show to him, you will understand. See, for example, my suggestion would be that you take not only the same cluster, you go to the neighboring cluster also. I am sure that your this classification will be very high and you will get it.
Yes.
Now his claim is that why late classifying or late classifying, what is that? What it was, how it was. Right? So you come prepared with that and explain to him. Right? So you must see, including the neighboring cluster, whether he tells one, you check also whether is the element lying in cluster 2 also, neighboring cluster.
Yes.
Right? Now how to find out the neighbor of one, you have to know that. That's basic algorithm. Okay?
I have built the graphs for all the databases, so I have to submit them. I have to submit.
Yeah.
Submit everything on the report.
Yes.
There are my two concerns. One is that whether it is working or telling you some useful information about the quality of the image.
Yes.
How you justify that after doing all of you these things, I will be giving an image, right?
Yes.
You will be telling me the quality.
Yes.
I am not interested in all these 8 parameters and all. That is being done for you. You are saying that out of this 1 to 5, it is good or whatever, right? The thing is that whatever you are saying, is it correct? Because you know that you are using 8 things.
Yes.
Out of that only 2 are suggested by you.
Yes.
So seriously, I was interested because I know always thing is working. I was interested in that.
Whether we can add some more.
Yes, or you have added something or not, because if you are using occlusion, you are using specular reflection, you are using focus, defocus, everything. So because of that, it will be, I mean, given the image, you will be telling me that okay, it's good or bad or whatever, and it will be consistent also, because you are using the existing one. I was interested to see that whatever you have said about these 2 things, are they working? Because that's the only thing that you have done, right? After that, you have used the same framework and all. So that is what I actually wanted to see, that with respect to these 2 parameters, what you are saying are good. Are they really good? Or what you are saying are bad? They are really bad. Are they able to do? Otherwise, you know what is happening? That even though you are taking these 8 parameters, those 2 parameters are not playing any role, because all this classification and clustering, they have not used, they will not have considered those parameters. Am I correct? So that actually I wanted to see that how much impact those 2 parameters, because I feel that if the 2 values are, I mean 2 centers are distant, then our assumption actually fails, and then there should have to be some distortion in the normalized image to try to show that. Okay. Okay.
A lot of issues are there. We are complete test results. You are supposed to show all the test results.
Yeah. So directly coming to the test results, these are the results. This is on the 30 cross 30, but I have done 500 cross 500 results also. But the thing is that LBP results are not good as written in the paper, but blob, you can see the results are. I think they are okay.
He has fused 2 features.
I have not fused 2 features because there are these 2 features. I have to randomly choose these. I need to one from this subset and one from this subset and fuse them. but the blob, as you can see, the results are okay, but the LBP results were not good. So
Not
not
26 and 12%.
yeah. So I don't think I have coded the LBP myself. I was double checked it yesterday, but I didn't find anything wrong with my.
And you,
Well, again, we will see that. Okay.
So these are
What
the
he has
just
said
on
is that
500 plus
500 subjects.
500 subjects blob results only, because LBP I didn't.
You have rejected that and only fused against blob or no?
No, I have not fused anything. I have
Only the three blobs
these
results
three
you
blobs.
have given. And all of them are having the similar result.
Yeah,
So which one is the simplest one?
with blobs, only blob 6.
Blob 6.
This is this means runs the fastest and means
Other than the fastest one.
Yeah.
That has to be. Now you have to see your LBP thing and then you fuse it.
these are only means results. I have the graphs.
You are showing the graphs, that's okay.
I will call the cover.
In the present report, you will be writing that.
So, I mean, these are only the
So you have a subject is 500 subjects.
500 was 500 IITK.
500 cross 500 means that 500 subjects.
Subjects and yeah.
First session and the second session.
First session and the second session.
Second session is matched with the first session. You have never matched the first session even with the first
No,
session.
no.
And also some part of the session 2 you could have taken into session 1 also. You increase the number of images, not subjects.
Even though he has huge amount of database, but the problem was that how much time it was taking to complete?
This took means only blob means each one takes 7 hours and 500 cross 500.
Yes. So LBP then the only issue is that
LBP was not working, so I didn't check for 500. I only
that's fine. So it's like
So
that.
LBP will also check for that. One LBP वहाँ पे लगा. Last TV, what is last TV?
Last time,
What is the last time what you have done that? you
yes,
have
I'll continue from that point itself. My algorithm last time it was just based on just scanning rows and then column. And the algorithm was last time we just suggested was scanning the rows and getting the finger boundaries and then scanning the rows.
Okay.
So last review, you wanted to know the running time, how much it takes to for an image. If I am getting the exact knuckle print, the last paper which Aditya had done, he is not getting the exact thing. And then testing it on the database and rotated images, and in case the fingers are skewed, sort of thing, if it is overlapping or something. So this is profiling. I have tested it on like 2 folders, 12 images, so it takes about less than 10 seconds. So sub 0.85 seconds per image about. This is the profiling of that.
0.85 seconds per image, that's the segmentation.
Segmentation.
Okay. I mean from the 4 the single print, you are getting 4 prints saved.
4 print that I have not cropped it, I have just
Okay. You
boxed
have
it.
got
I know where the boxes are there.
That's it.
Next is whichever I have tested in the database, so whichever answer I am getting the exact maximum point.
Provided they are separate.
Yes. So tested on IDK database, that is about 1007 into 12 images. So I got error for 1435 mainly due to these were rotated images.
Rotated this way.
This is. There was no case where there was skewed fingers or something. And for that, whatever I have done after that is I have implemented another algo. The one case is like this. Suppose in this case it is slightly rotated, so this thing overlaps. So if I scan it, I'll not get the end of this finger. Both the fingers will be clubbed together. So you can, if you just apply an average filter, complement, binarize the image, complement and then average filter, you can get the image like this. And there is a function, built-in function which will find the connected components. So I can get this and I can make a bounding square on that. So I have made this. So there are many smaller this thing also, connected components somewhere here and also here and all. So what I have done is in this I wanted to identify this finger, which is the topmost. Generally, what I have seen is this is the one which is having the maximum, which will determine the angle of whatever is the rotation. So in the same function you can get which is having maximum area, bounding area, and all the this points. So topmost one and which is having maximum an area which is greater. Suppose I can have a bounding rectangle somewhere here also, which is smaller, which is more
largest rectangle.
not largest, sir. It should be more than the average. Like if I have some point or something, some smudge here on top of it, then that can also, if I just take the topmost bounding rectangle, that can, so I can just identify this, basically I can identify this finger, and it is like if you the basic assumption is the finger is symmetrical, otherwise or top first, that is only
only the middle finger
top part should be symmetrical. So like if it is twisted, the ratio of the ratio of the area will give you the angle, and we can find out the angle. So this is what I have. Then I have tilted the image and applied the whole algorithm. So I am getting out of these are the results. So 520 images out of these are errors. These are mainly due to like oblique fingers. The finger top were not symmetrical. So I was not getting the exact angle of rotation. And so that's it.
It's a good number, right? 520
of 12
images.
The problem is that you are not able to get the correct orientation of the image, the finger.
Yes.
But as I told you that we can use the thing of Nishan. So
actually, what he has done, while in his algorithm, while finding this thing, he has found out the segmentation also.
Yes.
He has integrated it together. Now, like if I apply it, then it is as good as then mine it is totally going.
So it is up to this time. But sir, because if you don't know so what he has done is that he has done for all of the orientation.
All of the orientation, he has done.
And anyways, I mean, if we are failing, because 520 is a good number, and if we fail that much, then the accuracy will not be good. But okay, so orientation computation is a problem for your thing. So if it is solved, or you know exactly that what is the orientation of the image, somehow fast, some fast manner, then your algorithm will work.
Okay. No, the symmetrical assumption that if you can break, then will solve it. Right? Instead of symmetric, if I do some other arrangement geometrically, possibly your thing will work.
Yes. Is that?
Accuracy is not very good.
You are not getting good results? Very bad results?
Around 35%.
What is the CRR?
CRR is
You have not calculated. It's a Minutiae cylinder code. You have computed everything. I mean, you have done the complete implementation.
Yeah, we have done the complete implementation, but we are not sure whether there is a problem with extraction or there is a problem with the parameters of MCC.
There are something like 20-25 parameters, and they are all written in the paper. So you have chosen all of them.
Yeah, and I tried to tweak around the few parameters, but it just degraded the efficiency.
And you are sure that you have understand it completely?
Yeah, I have understood it and coded it right. I mean, I generated I took a Minutiae template, I rotated it by a few degrees and translated it and compared with the original, and I was getting 100% accuracy. So it means it is invariant with respect to translation.
Okay, so you have done this. Okay.
Our project is on fingerprint recognition. For Minutiae extraction, this pre-processing.
So that's the Minutiae cylinder code. So they have divided and done the both have.
No, earlier it was first thing 9250. It was in 4 slabs in the weight. It was absent. Am I right? Then you started with the 4 slab. Now you changed to fingerprint.
It's 4 step only, we haven't done the 4 step part.
No, he started from the beginning, it's a fingerprint.
But sir, this part is the same, he has to just extract the features, so that's 4 step. No,
No, you're supposed to do the
Yeah, I have to do the combination, but we haven't been able to do the solution.
How they are
Together like initially you were doing something else and after that you have decided to do the MCC.
No. You possibility was not there.
I was doing MCC comparison for the start.
चलो अभी तो देख लेते हैं बाद में
Recrossing minus extraction and removing false minutia. I use CN number, and for removing false minutia, I calculate distance between every pair of minutia.
You tell me, have you got the result of false minutia? That is important.
I have extracted more than nearly 30 minutiae, and in them, if I check manually, only 3 or 4 are false.
So it is 10% false.
Means I checked only for one image, so means
Then
I do not
know. See, what we wanted actually, where we are facing the problem, that whatever minutia points we select, they should be true ones.
they are not, means whenever there is noise, I am getting some false minutia.
The false minutia comes from the noise only.
Means when there is high noise, means when the noise is
So
greater than.
could you, that is the issue.
But I think that
Not
they
complete.
have actually attacked most on the minutia cylinder code coding.
No, but he is not telling, he has started with this.
Removal of false minutia. Acha, for here. Okay.
Some work mostly here and some work there.
Okay. He has contributed in for removing false minutia and some work in the minutia cylinder coding. You have done. He has done something like the removal of
He has
false
done the complete extraction.
extraction.
Yeah.
Okay.
Minutia extraction.
Minutia extraction. So you have some images.
I don't know if this is the output x and y and theta and the type of minutia. And these are the images. This is true, this is true, this is false, this is true, this is true, that is true, this one is true, true, this is here some noise is there, false.
This you have computed using which algorithm?
My own.
Your algorithm. So what is that algorithm?
I use CN number, crossing number.
So you have got minutia,
Yes,
and then how you have removed the false minutia?
well, here threshold. I calculate distance between every pair of minutia, and if the distance is less than the threshold, means for small of noises, both the points considered, both the minutia will be, I neglected both of them.
So if you have 5 minutia, then 5 C2 distances you have calculated.
Yes.
Then
And if distance for every distance, I compared with some constant threshold.
some fixed threshold.
And if the distance is less than that,
Okay. Then
I remove both the points.
both the points.
Yes. Means they are very near.
Okay.
So, but one of them may be true.
No, actually, sir, this threshold will be some constant into edge width. Edge width is this the edge width. So I did not say where. Means
Well,
only.
you will be looking at the 2 points are there,
Yes, sir.
right? And one has come like this. Guess what happened, no? So this is a minutia point. But above one is not a minutia point. Right? No, you are telling that no, so that is a noise. Okay, I understand. What you are telling? That even this is small one, this is a, you are considering, this is not a minutia.
Maybe I am removing some true minutia. And means it will generally.
But
the
what
noise-
about you see this right hand side? No, all this A is 1, 2, 3, 4, 5, 6, seventh line, seventh line.
Sir?
No, just make it next one, next right hand. What you are drawing the conclusion here? The
Here,
two and,
here the line is like this, so there is no noise. As far
okay,
as
there
both are
are
correct.
two minutia points.
Yes, sir.
Okay.
So you are still getting some minutia, false minutia points.
Yeah, maybe, yes sir, 3 or 4. When the noise is this much more, very high, here the noise is very high. So here I am getting one false minutia. When the noise is high, I am getting false.
You cannot draw the same noise. You know, it creates part of
We have some very noisy images.
This is part. Here, yeah.
But still you are getting several.
Not several, but yeah.
How much?
Near here.
How you justify that you are able to remove maximum false minutia? With what accuracy that you can say that your algorithm is working? Because now I think that after presentation, he will be saying that whatever minutia you are giving him, you are giving the minutia to him, and he will say that they are not correct, right?
It may be possible.
It may be a possibility, or otherwise your code there are some parameters, or you are not able to get those parameters.
So both of you, my suggestion is both of you sit today itself, or tomorrow, or so that they get some time
Yes.
to modify, and then finally tomorrow.
Yes. Yes.
Yeah, I was thinking if I could get a correct minutia extraction code, I could just check my phone. Then we
But
can
how to get it? That is the problem. From day one once, I'm looking for that one.
What you can at least what you can say is that they can
You
use that.
suppress some of them which are not correct. You suppress and give it to him.
Because what he is saying is that he has manually taken a minutia Humaya and translate key, and then he is getting.
So he gives him now.
Yes.
That by removing those minutia points, which manually can see that they are false, remove them and give it to him. Let's see.
So what I am saying that today I will sit with them and also with Virendra Meena, and I will say that he will spend some time and I also spend some time, and then try to see that why it is not working. Because you are saying it is 35-40%, which is absolutely, I mean, you have done some random mistake in the coding, or whatever he is giving something.
I think either the parameters are too off by the value they should be.
Yeah, so we have to see the parameters, but these parameters are from that FGC.
The image size is different in FSC database by
yes.
a substantial
So
amount.
you require some tuning in the parameter. That is why, because we have in arena, he requires it badly. So he will have to see, and then we'll see that how much you can do. You wanted to tell also about your part.
No, so finally, well, he is or he will bring his thing.
Sir, my problem is given a segmented image and given the scores of 4 fingerprints, and I will use them to give a single fingerprint score.
Yes.
And
So you have the minutia points thing.
I have.
You have the for each finger, and also some accuracy you have obtained from the ABC area. No. Otherwise, how are you going to prove that? Weighted mean method.
Sir, I actually done training.
In training, you got the accuracy.
Yes.
Tell me which one is having what accuracy? What fingers?
I haven't calculated for individual fingers, but overall it is giving.
His accuracies are very good.
This is
Even better than the Nishan.
No, Nishan's one is different. First, you got the. Let me understand. You got the force flag.
Yes.
Then you have used the least force flag.
Yes.
Detect crop dwarf.
Yes.
You have used the least algorithm on each of them.
To get minutia point.
To get the minutia point.
And then I use the next algorithm to get the matching score of 2 minutia.
Matching score for each of them. Okay. Then up to this is clear. Uske baad fusion. What is that fusion? This is the thing I know.
I have done that weighted laser.
What is weighted laser?
Weighted is calculated and.
How did you get weight?
NI
into
DSR.
What is DI?
Minutia point detected for each
Number
finger.
of minutia points detected
for each 4 fingers. So number of
and density
is the density of the each points in the IP.
This is a quality parameter. DI is the quality parameter.
I don't know the quality.
DI is the quality parameter. This is point, right? But if the number of minutia points becomes false, then you are in problem. Least algorithm gives you false minutia points.
But he has used the density, so
that will take care.
There are
number of points divided by the total area. What is the density? How you define the density?
I will tell you. We can say the density is number of rich points, some n by total number of with size of the image.
Okay.
That we can say the density. And why I have taken two, because for suppose there are two similar images, one has some Minutia points, one has some
That
Minutia
is
points.
the density of these points, not the Minutia points.
Not the Minutia.
So it is like that, given the image, how many ridges, ridge points are there divided by the size of the
What is this point? Total or black?
total number of black pixels, right?
Acha.
It is a bit different. And
That is also quality parameter.
yeah, that is also a
Quality. That is also quality. Okay. Actually, what I would prefer, I would have preferred that you should have taken some trained data and then you got the accuracy of those and also this parameter. Accuracy, because that plays role. This finger gives you the good result, this way you are giving equal importance to each
I
other.
have done check manually which finger is giving more results. I have
So-
found that middle finger and ring finger give not
These
intense.
two gives the good figure.
For
Fine.
this database.
Fine. But
Maybe
you
some
then you
middle
should have
and-
given higher weightage on this.
I have tried that also.
But
There
you
is
have
an
not do
improvement. I have implemented that also. Improvement of 0.0 per
Huh?
Over this there is above this is 99.45 and that is 99.49.
See, in this case, remember, increasing 0.01% itself is a challenge.
I have done that.
Because in the fingerprint, increasing after 99, if you increase 0.01%, 0.02%, that is also very good for us.
I have done that.
Right? Because you understood. So that you put all those information, then we will verify which finger gives the good result. That way to put later. But your thing should be generic. Right? So that's how you do. Okay. So Aditya, you also
yes,
see
yes, I see that. Because if the results are correct, then it is a good,
it will be very useful for us.
very useful. Because it is like tweaking the Nishant work and the accuracies are getting even better than that. So just we also tweak the thing because he has, used the quality parameters and accuracy. And if
Now,
this,
what you have to do, there is a segmentation algorithm here.
yes, sir.
That one you model this thing,
Yes.
challenge against Nishant.
Yes.
Okay? So this is a today, right? This one? The force flap prediction.
Segmentation.
Huh?
We just
It's gone.
No, so he is not. He is coming.
So you both of you sit together, and now that force slap segmented things, you add his routine. Well, he takes 2 seconds, he goes. Right?
Now we
Combine both the things.
You also have a demo thing, right?
Yes,
Yeah,
No, not that.
I will see. So he has also given a demo part also. So in that it actually takes 2 images.
No. I have done both identification and verification.
That I know. I'm saying that for verification,
Verification
it
takes
takes 2 images. Complete images or 4 slab images.
Not completely.
So it is take 4 images and 4 images, right? So other than what we will do is that it will take now 4 images. Not the 4 images, it will take only 2 images, big images. And his algorithm will first drop.
I will give you that.
More
Let's
thing,
do it.
and then your algorithm will
Sit down, sit down.
sit
Sit down first and don't roll. Huh? Okay. And you see this thing is demo is not
Result. You wanted to show?
No.
Okay.
I have to give this one. There are some push marks I have to give you now. Can you read some of the 48 but the first one. 55. 1, 2, 55, 36, 9036, absent. So they will be marked absent. 9305, 9305, that is 9250, 9522, 9522, 9547, and then 9581, 31, Samiji, coming. So 25, 9425, 9002, then 9467, then 9408, 9408, 9271, 9271, 56, just now, 9181, then 9164, 9164, 9610, take your thing, 9451, and 9309. So, all the best, and I am expecting the exam will be between 2 hours or 3 hours. I am working on it.